Cambridge IGCSE O-Level Computer Science, Paper 1 for the session October-November 2024, Variant 1. So let's start with question 1. The size of a file can be measured using different units. Tick one box to show which of these is not a unit of measurement for a file. A bit is basically 1 unit, 8 of which makes up a byte, which is a unit of measurement for a file. So it's not what we want, right? A nibble is basically 4 bits, right? Which is half of a byte, which is also a unit of measurement. So a bit is the 1 unit, 4 bits are a nibble, and 8 bits or 2 nibbles make up an entire byte, which are all a unit of measurement for a file. A bot is the only wrong answer, which we want something that's not a unit of measurement. B. The size of a file can be reduced by compressing it. Give 2 types of compression that can be used to reduce the size of the file. We only have 2, which are lossy and lossless, right? Lossless. Give 3 benefits of reducing the size of a file for storage and transmission. So first of all, less time for transmission, right? Less storage, right? Lower bandwidth when we're transferring files over the internet. More likely to meet file size limits, right, by email clients or whatever. All of these are sufficient keywords for the 3 marks for this question. So for question 2, a student has a smartphone. Identify 2 input devices that can be built into this smartphone. So we have a touch screen, right? That's an input device because we're touching on it. Microphone, sensors, biometric devices, buttons, all of these are examples. Now, 2 output devices for smartphones are, for example, also a screen. A screen is both a touch screen is both an input and an output device, right? Speakers, right? This kind of stuff is some output devices. For example, actuators sometimes. Okay, so part C. The smartphone contains secondary storage. Explain the purpose of the secondary storage in the smartphone. So to store files permanently, right? Because main storage, right, primary storage can store files, however it's volatile, it's not permanent. When we store it in the secondary storage, we want to store it permanently, right? So if you explain that idea, so stating that idea and explaining it, right, will get you the 2 marks. Something else is to create virtual memory. Okay, that's another use for secondary storage, which is basically when we need extra RAM. Okay, instead of crashing, we use virtual memory. So part II, identify the most suitable type of secondary storage for the smartphone. Explain your choice. So secondary storage type. So the best choice is, of course, solid state, right? Solid state for a smartphone, of course, it's solid state. Explanation, many reasons, right? No moving parts, small in size, lightweight, durable, faster read-write speeds, runs at a cool temperature, larger storage capacity. Many reasons, and all of them are correct, and all of them will get you those 4 marks. Of course, 1 mark is for here, and 3 marks are for the explanation. One of the easiest 3 marks you can get. Okay, multiple reasons. Question 4. A user enters text into a computer system using a keyboard. An American standard code for information interchange, which is ASCII, character set, is used to convert the text to binary. Identify one other character set that could be used to convert the text to binary. You could mention extended ASCII, but just to be safe, mention Unicode, right? The character A is represented by the denary ASCII number 65. The character M, small m, this is capital A, the small m, is represented by the denary ASCII number 109. Convert two denary ASCII numbers to binary. So basically 65 into binary. Okay. What is the highest power of 2 that's just below 65? So we have 1, 2, 4, 8, 16, 32, 64, right, and 128. 128 is larger than 65, so forget it. 64 is just under 65, so 65 minus 64 is 1. 1 minus 1 is 0. So we use 64 and 1, and then fill in the rest with 0. So our answer is 1, 0, 0, 0, 0, 0, and 1, right? This is it, but just we need to put another 0, so it could be 8 digits. Now, in terms of 109, we do exactly the same thing. 128 is too large, so 109, we subtract 64 from 109, which is 45, and we put 1 over 64. 45 is still over 32, so 45 subtracted by 32 is 13, and we put 1 over the 32. 13 is smaller than 16. We won't use 16, so we put a 0, or we can use 8, which will give us 5, right? And then 4 and 1, right? So this number would be 101101, and we put an extra 0 just to make it 8 bits. So it could be a byte. Now, part I, convert the two denary ASCII numbers to hexadecimal. Well, since we already converted them to binary, it's very simple to convert them to hexadecimal. Let's take the first number, 01000001. We split it into 4s because every hexadecimal digit is 4 binary digits. 1, 2, 4, 8. Only the 1 has a 1 under it, so this is 1. 1, 2, 4, 8. Only the 4 has a 1 under it, so this is 4. 4, 1. That's it. Let's take the second number, 01101101. 1, 2, 4, 8. 8 plus 4 plus 1, that's 13. A is 10, B is 11, C is 12, and D is 13. So this is a D. 1, 2, 4, and 8. 4 plus 2 is 6. So 109 is basically 6D. Okay, 6D. So now let's move on to part C. The character Y is represented by the binary ASCII number 01111001. Convert the binary ASCII number to denary. Okay, so let's firstly write it out in a bigger form. Those are 4 ones with 2 zeros and a 1 at the end, right? So 1, 2, 4, 8, 16, 32, 64. So 64 plus 32 plus 16 plus 8 and plus 1. We take whatever has a 1 under it and we just add it together. So 64 plus 32 plus the 16 plus 8 plus 1. And if you add everything together, you will get 121 in your exam. Convert the binary ASCII number, right, to hexadecimal. Okay, so if you want to convert it to hexadecimal, we erase everything here and then we split it into 4s, right? So 1, 2, 4, 8, and then these are now 1, 2, 4, 8 because we split it into 4s. So 1 plus 8 is 9. 1 plus 2 plus 4 is 7. So 7, 9. That's it. So part I, a logical right shift of 2 places is performed on the binary ASCII number 01111001. Give the binary number after the logical right shift of 2 places is performed. So if we shift everything to the right, so let's zoom in here. We're basically taking away those and writing the number starting from here. So 0, 1, 1, 1, 1, 0. However, now it's 6 bits, so we add 2 zeros in the end. That's it. That's a right logical shift of 2 places. Very simple, okay? If it was a left shift, you would have hidden these 2 bits and started from here, right? So part D, the character T is represented by the binary ASCII number 01010100. The character small t is represented by the binary ASCII number 0310100. Add the two binary numbers using binary addition. So 01010100 and 01110100. If we add them, binary addition is very simple. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. Just know this and you're set for any question for binary addition. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1 is 0, carry 1. 1 plus 0 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 plus 0 is 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 0 plus 0 is 1. This is our answer. So, for question 4, a company decides to create a network for its devices. All the company devices are within a single room. The employee will need to use their devices to send data to each other and share files. The company decides to send data across the network using packet switching. An employee sends an email to another employee. The email is broken down into packets. Describe the structure of a packet of data for the email. So the data packet has 3 sections, right? The packet header, right, which contains the address, right, for the destination, and it has a payload, right? It has a payload that contains the main data for the email, and it has a trailer that contains data like the error detection system. Okay, so if you mention any 3 of the bunch of keywords I just said, you'll get the 4 marks in this question. Okay, so for part B, the company decides to use parallel full duplex data transmission to send the data across the network. Explain the reasons why the company have chosen this method of data transmission. Firstly, what are the advantages of a full duplex data transmission? Well, it sends data both directions at the same time. Data may not need to travel a long distance. It sends multiple bits at the same time. It uses multiple wires, right? So the transmission speed of the data will be fast. Any of these reasons, right? State any 4 of them, you'll get the 4 marks. Give 2 drawbacks of the company using this method of data transmission. So just the disadvantages of parallel full duplex data transmission. What are the drawbacks? Firstly, more interference, right? More interference, of course, due to more wires, and the data may be skewed, right? These are some of the disadvantages for parallel full duplex data transmission. Give one other method of data transmission the company could have chosen. Of course, this is a pre-mark question. You could say serial simplex, right? Serial half duplex, serial full duplex, parallel simplex, parallel half duplex. Any of those would give you this mark.